Right, lesson 229, electric motors, polyphase. Of course, poly meaning many, or in our case, three. So first, right off the bat, we see this series of three sine waves. When the three-phase supply circuit is connected to the stator, the three currents start at different times. That's why we have three phases, because they sort of hit their peaks and valleys at alternating times. So your B phase starts 120 degrees later than A phase, and then C phase 120 later than B phase. Of course, the significance there, 120 for A, B, and C added together is a full 360. This is shown on the sine wave graph, which I think does a nice job here. You can see each peak at a different time, evenly spaced. They cross zero at a different time. They hit their valley at a different time, evenly spaced. The direction of rotation of a three-phase motor can be reversed by changing the direction of current flow through the stator windings. How do we do that? Well, simply by swapping the connections on any two of the three line conductors. So you can switch your A and B phase, your B and C phase, your A and Z phase, doesn't matter which, that will reverse the rotation. So you could rotate your T or L leads on the motor itself. Usually, most times you're going to do that maybe at a breaker panel, or most commonly, I would say, at a disconnect. You have a little more room to work inside of it. Think about a disconnect. But either way, swap any two of the line wires at basically any point that is convenient. We're going to talk first about a 6-lead motor. So you can see here, right away, they tell us for a 6-lead motor, each of the three windings has 2 leads. You can really compare this to your transformers. A winding has 2 ends or 2 leads coming off of it. In this case, we have 3 windings, 2 leads apiece, 6-lead motor. Here's some various connections that can be made. The leads are connected, so the windings are connected in either a Y or delta configuration. A dead giveaway, if it's Y, you're going to have 3 motor leads coming together, all connected. That's that central point. If you have 2, 2, and 2, that should be a dead giveaway that we're just connecting the ends of this delta. So we have a delta connection. For some motors, we have only 3 leads available in the terminal box. With these, the manufacturer has already internally made some of these connections for us. Otherwise, it's the same as our last slide. I think this is a really nice little image here. 3-phase motor leads are numbered spirally towards the center. So kind of interesting. You got to follow these spiral lines here. We have T1, T2, T3, and then we just kind of keep spiraling in towards the center. Same on our delta. That's a nice kind of rule of thumb to imagine what's going on. I think that's a really nice graphic right there. Many 3-phase motors are made so they can be connected to either one of 2 voltages. This is a very common diagram that we see here. We see one for high voltage, one for low voltage on both a Y or a delta. So a lot of your motors are going to be rated, 230/460, 120/240, whatever the case is. Whatever the lower number is, you would use your low voltage connection. Whatever the higher number is, you would use your high voltage connection. And you're going to have this diagram printed right on that motor at some place. Dual voltage 3-phase motors consist of 6 individual windings, 2 for each phase. Since there are 2 windings for each phase, these motors have 12 leads. And again, think about how we connected transformers. You would either parallel or series connect different windings. Same theory for a motor, right? And here you can see that in a delta, in a Y connection, how they make those various connections, how that corresponds to sort of this numbered nameplate diagram. With these, manufacturer has made the required T10, T11, and T12 connection internally. So now you're only going to see 9 leads out here. Again, same as the last slide, they've just already made some connections for us. Quite often you'll see that. That's very common. 9-lead dual voltage motors can be either Y or delta wound. So over here, 2 individual motor windings and their leads are insulated from each other and from the motor housing. Between each end of the winding, an ohm meter should indicate between 0.2 and 20 ohms. So be careful if you're trying to take some ohm readings, some resistance readings. If you read between the leads of any one coil, you will have continuity. You should have continuity. And depending how they're connected, you may have continuity between two coils if they're connected together in series, as they often can be. Insulation resistance checks between any lead of any motor and the motor housing should be infinity. So essentially, if we're reading things that should not be connected, so for instance, let's step back over here, essentially the way this one's connected, if I take with all these connected, if I take a ohm reading between any of these L1, L2, L3, I will read through that because these are actually all connected, right? So here we see a motor nameplate, pretty standard stuff, provides important info necessary for proper application. Big ones for us naturally are going to be our horsepower, our amps. We should see our voltage over here. In this case, it's a 460 volt. A lot of other stuff, very relevant stuff, but for the most part, that's a big one. 3-phase here, of course, we need to know. Here, they did I think a pretty nice job of sort of tabulating a bunch of common formulas for you. Listen, I'm not going to drag you through all these. We looked at some of the basic ones in the last lesson. That's a really nice reference. I would make a note of that, bookmark it, whatever you have to do. Again, apply these formulas, use a little common sense here. I'm not going to drag you through all of them here today. But as I said, bookmark it, note it, wherever you gotta do to be able to recall that later on. So there again, pretty short and sweet video. This one, I think the book does a great job of putting the information in front of you. Once again, make sure you are aware of the code references. Read through that content thoroughly.